Hey everybody, welcome to Math with Ace. We are focusing on statistics today, and I wanted to revisit sampling because I know that sometimes it can be confusing when you're talking about stratified versus cluster sampling. I think that systematic sampling is very easy. You do to think about or consider when you start at some random number and then you are systematically sampling every certain number after that. So for instance, in systematic sampling, you're talking about maybe you randomly start at the fifth person, some random number, and then you sample every 12th person after that. So if you had a list of students who was alphabetically listed from the registrar, and then you said, okay, I'm going to start at the fifth person, and then you go every 12th person until you get through the entire roster, that's considered systematic sampling. Convenient sampling is when you are doing something that is convenient to you. You're accessing people that are convenient to you. Not very good. It's not random. It doesn't allow you to generalize to the population. That's a different type of sampling that we have. There's multi-stage sampling where you sample from, you use different methods to sample. And then you have a simple random sample. So a simple random sample involves randomization where every sample of a certain size is equally likely to be chosen. And what that essentially means is in your entire group, you don't have things separated so that if you wanted to get a sample, if you had maybe dogs and cats, every sample of size 5 is likely to be chosen. So what that would look like is 5 cats could be chosen, 5 dogs could be chosen, or a mixture. But if you were to split by cats and dogs and then sample it within, that's not a simple random sample because every sample of a certain size is not able to be chosen. Okay? Okay, so as you can see here, I've written the definitions of those 3 different types that I just discussed. Systematic, you begin at a random starting place. You can use a random number generator to find your starting point. And then you sample every kth individual until your sample size is chosen. K just being an integer, like every 10th, every 5th, every 12th, something like that. And then until you get your sample of size 50, or you go through the list of individuals you have. Sometimes you need to circle back. It just depends on the parameters that you're given. And then again, convenience is where you're sampling individuals that are convenient or easily accessible. And simple random sample is that every sample of a certain size is equally likely to be chosen, meaning every sample of size 5, every sample of size 10, every sample of whatever sample you're dealing with in the given situation. Now, the two that get confused a lot are stratified and cluster. Stratified groups by similarity, they create homogeneous groups. Once you have these groups that are similar, you do a simple random sample within each strata to get your total sample. And simple random sample is abbreviated with SRS as a reminder. Let's say in this grid here, we have people in an auditorium and they're in high school. And in this auditorium, they're seated in these rows across by grade level. So we have ninth graders in the first 2 rows, 10th graders in the second 2 rows, 11th graders in the next 2 rows, and then 12th in the last 2 rows. So these are ninth graders. These are 10th graders. These are 11th graders, and these are 12th graders. So I'm going to say ninth graders are this blue area. Okay, let's do another color. Let's say 10th graders are pink. Okay. Let's say that 12th graders are green, or 11th graders are green. And then 12th graders would be yellow. Now, the way that I have split this already, you can see that they're grouped by a similarity of grade level. So the different colors are actually different strata. So I'm stratifying by grade here, where grade is the similarity that they all share. And if I wanted to get a sample from this group of individuals, I would do a simple random sample within each strata or grade level. Let's say I needed a sample of 100. So within the 4 different groups, that means I need 25 from each group. So I would simple random sample within the 9th grade to get 25 randomly, simple random sample within 10th grade to get 25, simple random sample within the 11th grade to get 25, and then simple random sample within the 12th grade to get 25, and that would be 100 total. Clusters are where you create groups that are heterogeneous and not similar. And some books will talk about clusters being based on populations, like you would grab your based on proximity. The way that I have learned it and the way that I've instructed it for the last, 15 years is that clusters is where you create groups that are mini populations, like MINI. So they're representative of the population, but they're groups that are representative like that. So a cluster is where you would not create similarities, you would be heterogeneous. You're trying to create groups that are similar to the population makeup. But let's say, like you're talking about the United States, sometimes people will consider a cluster like this city versus that city versus this city based on where they're located. When you create a cluster, what you do is you do a simple random sample of all of the clusters to select different clusters, and then you randomly sample the entire cluster. So you do a simple random sample to get a certain number of clusters. And then you sample the entire cluster. So in my drawing of grade levels, if I have the rows are different, are based on the different grades, which creates strata. If I was to go vertically and do seat numbers, this could be a cluster because in that cluster, I have 9th, 10th, 11th, and 12th grade. So that's like the population. So I could break all of these seat numbers into their own clusters. And then I could number the clusters and use a random number generator to select the cluster and then sample everybody that was in that cluster. Now that's not broken up evenly to give me 100 because there are 8 people in each group, but I could do 12 of those, or I could do, there's actually not 100 people here, but I could do whatever number of cluster I need to get me to the sample size that I wanted. So I could use a random number generator, and let's say it pops out 5. Then that means I would randomly select everybody that's in that 5th group. So every single person would be part of my sample. Hopefully this helps kind of clarify a little bit more about the different types of sampling that you will see in our class. Thanks for watching.